Good morning, everyone. My name is Christos and I am delighted to present this session on industry engagement as part of the ERG 2 MOOC. The purpose of today's presentation is to walk you through the findings of our industry engagement survey, which was conducted to better understand the perspectives, needs, and challenges that industrial stakeholders face in the smart grid sector. As we all know, the role of industry in shaping the future of energy systems is crucial, and without strong collaboration between research infrastructures and industrial actors, innovation cannot translate effectively into practical, scalable solutions. This session will focus on the key insights gained from the survey responses, covering areas such as software and system integration, co-simulation, standardization, cross-laboratory testing, and industry engagement with ERG2. By understanding the viewpoints of industry players, we can better align research efforts with real-world requirements and ensure that innovations in smart grid technologies have a meaningful impact on businesses and society. I invite you to reflect on the insights shared today and consider how these findings might apply to your own work. Let's begin. The Industry Engagement Survey was designed as an initiative to actively involve industrial stakeholders in smart grid and energy systems research. Our primary goal was to gain deeper insights into industry needs, challenges, and expectations, as well as to increase awareness of the ERG2 research infrastructure. ERG2 is a collaborative effort that aims to provide research and testing facilities for innovative smart grid solutions. However, for the infrastructure to be effective, it must be closely aligned with industry demands. This survey was an important step in understanding how industrial users perceive smart grid testing, validation, and co-simulation, and what factors influence their willingness to engage with research infrastructures. A key motivation behind this survey was the recognition that early cooperation with industry can facilitate the practical adoption of new methodologies and technologies. Without active engagement from industry players, research outcomes risk remaining confined to academic circles rather than being applied in real-world scenarios. In the following slides, we will explore the findings from the survey in detail, covering key responses and insights from industry participants. To set the stage for our analysis, we first needed to understand the profile of our respondents. One of the initial questions in the survey focused on the size of their organizations and their areas of specialization. We found that the industry stakeholders who participated in the survey came from a diverse range of organizations, spanning from small and medium-sized enterprises to large multinational corporations. This diversity is important because different organization sizes have different capabilities, priorities, and constraints when it comes to adopting new smart grid technologies. Additionally, we examined the types of specializations within these organizations. The smart grid ecosystem involves a wide variety of players, including distribution system operators, energy technology providers, grid equipment manufacturers, and software developers. Understanding their areas of expertise helps us tailor research and testing activities to better support industry needs. These insights provide an essential context for interpreting the rest of the survey responses, as different segments of the industry will naturally have different perspectives on smart grid adoption and testing methodologies. One of the key technical questions in the survey focused on whether organizations integrate individual software modules and test them collectively in cooperation with vendors and other partners. This is an, this is an important issue because the energy sector is increasingly moving toward modular, interoperable systems. Rather than relying on single vendor proprietary solutions, many companies now seek to integrate various software components from different providers to create more flexible and cost-effective energy management solutions. The survey revealed that the majority of respondents already engage in multi-vendor integration and testing. However, many also reported challenges related to compatibility, standardization, and testing environments. This highlights the need for common testing frameworks that can facilitate the seamless integration of different software components. EDGRID 2 plays a key role in addressing these challenges by providing research infrastructure that supports modular cross-platform testing. By enabling industry players to test their solutions in standardized environments, we can accelerate the adoption of integrated, interoperable smart grid systems. As energy systems become more complex, cross-domain interactions between different grid components, IT systems, and market mechanisms become increasingly critical. We asked industry stakeholders how important it is for them to test their applications in interaction with components from other domains. The results showed strong support for cross-domain testing. Many respondents highlighted the fact that modern energy systems rely on interactions between multiple technologies, such as renewable energy sources, grid-controlled systems, energy storage, and demand response mechanisms. Ensuring that these different components can operate smoothly together is essential for reliability, efficiency, and scalability. However, respondents also identified challenges associated with cross-domain testing. Some of the key concerns raised included the complexity of setting up realistic testing environments, the lack of standardized testing methodologies across different domains, the need for better tools and infrastructure to support cross-domain validation. The feedback from this question underscores the need for initiatives like RG2 to provide industry with the tools and resources needed to conduct comprehensive cross-domain testing in a cost-effective manner. Co-simulation is increasingly recognized as a powerful tool in smart grid research, as it enables the integration of multiple simulation environments to study complex interactions between power systems, communication networks, and market mechanisms. We asked respondents whether they saw value in applying co-simulation within their organizations. The top 5 responses highlighted the following potential applications. Using Firstly, using co-simulation to refine and validate new operational strategies before deploying them in real-world settings. Secondly, integrating distributed energy resources with control systems to improve grid flexibility. Thirdly, combining different technologies and vendor solutions into a unified testing environment. Next, using co-simulation to predict and mitigate faults in grid operations. And finally, studying the interactions between electric vehicle charging infrastructure and power grid stability. While these applications show strong potential, industry adoption remains varied. Some organizations are already using co-simulation extensively, while others are still assessing its feasibility. Addressing concerns around implementation complexity and interoperability will be key to increasing industry uptake. Despite the potential benefits of co-simulation, the survey revealed a wide range of perspectives on its adoption. The responses were divided as follows. 8 respondents acknowledged the potential benefits but were not actively engaged in co-simulation. 2 respondents were strong advocates of co-simulation and actively pursuing its implementation. And 8 respondents were skeptical about its practical value or faced barriers to adoption. The mixed response indicates that while co-simulation has clear advantages, significant barriers remain, including technical challenges, resource constraints, and uncertainty about return on investment. To encourage wider adoption, research infrastructures like RG2 need to focus on reducing complexity, improving tool interoperability, and demonstrating clear business benefits for industry stakeholders. One way to overcome barriers to co-simulation adoption is through standardization. We asked industry participants whether they would be willing to contribute to the development of standardized simulator interfaces and smart grid models. The responses were promising. Some organizations already participate in standardization efforts through CRED and IEC TC57. Others expressed a willingness to contribute if opportunities were available. A few respondents were uncertain but recognized the potential benefits of standardization. Standardized interfaces and tool-independent models would allow different co-simulation tools to work seamlessly together, reducing integration challenges and making co-simulation more accessible to a wider range of users. To better understand industry hesitation toward co-simulation, we asked respondents about the limitations they foresee in implementing it within their organizations. Key concerns included high complexity and resource demands, Many organizations lack the technical expertise or computing power needed to set up and run co-simulation environments effectively. Lack of interoperability. Different vendors use different simulation tools, making integration difficult without standardized interfaces. Limited awareness and training. Some respondents indicated that their teams were unfamiliar with co-simulation techniques, highlighting a need for more educational resources. These findings suggest that for co-simulation to gain wider acceptance, we need to simplify deployment, ensure compatibility across different platforms, and provide better training for industry users. In this slide, we focus on the most promising research topics in co-simulation and the key challenges that need to be addressed. For question 11, participants highlighted three main research priorities. Real-time coupling of simulators with hardware, which was the top choice. This enables more accurate testing of power system behaviors before deployment. Integration of communication networks into power system simulators, crucial for improving grid reliability and cybersecurity. Coupling of physical simulator modules, allowing more comprehensive system analysis. For question 12, key challenges in co-simulation include the impact of distributed control strategies, ensuring decentralized control improves efficiency without causing instability. Cybersecurity assessment, addressing vulnerabilities in smart grid communications. Emergent system behavior, understanding unexpected interactions in complex situations. Computational time and fidelity issues, ensuring accuracy without excessive processing demands. By tackling these challenges, we can advance co-simulation as a powerful tool for future power systems. Question 14 asks whether ERIC-2, which integrates real-time simulation, co-simulation, and hardware-in-the-loop testing, adds value. The responses show a strong positive trend, with a significant portion of participants recognizing its high value. These tools enhance the accuracy and reliability of grid simulations, making them essential for future developments. The next question explores where these benefits are most relevant. Key areas identified include grid control, cybersecurity, ensuring protection against cyber threats, SCADA with DER controllers, improving flexibility and system responsiveness, integration of the flexibility market, aligning with real-time grid demands, network management improvements, optimizing grid operations, enhanced efficiency in simulation and testing, leading to time and cost savings. These insights highlight how ERGRID 2 strengthens power system innovation and operational security. Another area of interest was cross-laboratory testing. We asked how likely respondents thought it was that such testing would become commercially viable. The results were mixed. 5 were neutral towards cross-laboratory testing. 1 actively supported the idea, and 12 did not see it as commercially feasible. This suggests that while cross-laboratory testing has potential, there are significant barriers that need to be addressed, such as cost, logistics, and standardization challenges. Question 18 assesses the perceived value of its development. The feedback is mixed. 3 promoters see high value, 6 are neutral, and 9 do not see significant value. Next question explores applicable standards and technologies. 2 key recommendations emerged. 1. Monitoring and control of smart grids at a large scale, and 2. IEC 62850 standard and advanced communication technologies like optic fiber 5G for better grid management. This feedback highlights the need for enhanced smart grid standards and better communication infrastructure. Regarding the likelihood of applying for ERG2 to international access, 9 answers were passives and 9 were detractors. We saw there is low enthusiasm for transnational access, suggesting barriers such as logistics, relevance, or awareness. Regarding the likelihood of applying for ERG2 virtual access, there were 2 promoters which see some value in virtual access. There were many neutral answers, 10, and there were 6 detractors that showed that some skepticism remains. Virtual access is slightly more appealing than transnational access, but there is still limited enthusiasm. This may indicate the need for better communication about benefits or more user-friendly access. As the feedback from our surveys is reflected, it's clear that many valuable insights have emerged. Some participants shared that they were previously unaware of ERGID, highlighting the importance of spreading awareness about this initiative. Others recognized new ways of working, particularly in operational technology and the use of free access software. A key learning point was the value of co-simulation-based assessment methods for cyber physical energy systems, along with the availability of standard laboratory test services. Additionally, respondents emphasized the importance of accessing physical labs, databases, and virtual facilities, a critical resource for many organizations. One particularly exciting insight was the recognition of advancements in co-simulation frameworks that integrate hardware-in-the-loop techniques. This has strong implications for the future of real-time flexibility markets, such as demand response schemes and integration of analytic software and hardware components. These findings provide us with a clear direction. There is both interest and potential for growth in these areas. Moving forward, we must ensure that these opportunities are not only available but also well communicated and easily accessible. The survey results also provide insights into how engaged participants are with Ergid's research. When asked whether they would follow research updates, we received a mix of responses. Some participants expressed definite interest, particularly in smart grid simulations, while others indicated that their work is in a completely different field or that it is only indirect relevance to the organization. Some were uncertain but open to the possibility. On the feedback front, we received a simple but powerful message: good job. This reflects the positive impact of our work and the appreciation from our stakeholders. Additionally, there was strong interest in the survey results, with 12 participants sharing their email addresses to receive aggregated and anonymized findings. This highlights the importance of keeping our community informed and engaged. Thank you very much for your attention.